A commercial building fan wall case study is convincing only when before and after use the same measurement boundary.
If airflow, static pressure, operating hours, weather or occupancy changed, a lower power number alone does not prove the fan wall caused the result.
Begin with the building requirement.
Record design and actual airflow, supply static target, ventilation schedule, temperature and humidity duties, filtration state, sound limits, electrical service, available AHU space, access route, and downtime window. The retrofit must preserve indoor air and comfort obligations, not just reduce motor input.
Survey the entire AHU pressure path. Outdoor and return air dampers, filters, coils, heat recovery devices, silencers, transitions and discharge geometry all consume pressure. Measure a representative baseline across expected load and filter conditions. A single free air fan point cannot describe the installed system. Now lay out the array inside the real casing.
Divide total duty among modules, then check common inlet and discharge plenums, spacing, frame blockage, cable routing, service pullout and sealing around the wall. A neat grid with uncontrolled bypass can move less useful air than the drawing suggests.
This real AHU image shows multiple plug fans installed as an array.
It proves physical architecture, not a named customer result. Project airflow, pressure, power, sound and savings still require the corresponding design records and commissioning data. This Longwell 3x3 FanGrid clip shows the modular frame and hardware. The value is not the number 9 by itself. The engineering question is how the modules share the common plenum, how one unit is isolated for service, and how the remaining array behaves when a module is unavailable. Plan installation as a controlled sequence, safe shutdown, remove existing equipment, prepare the casing, install and seal the frame, connect power and communications, inspect rotation and clearance, then perform staged startup. Confirm weight, lifting path, electrical protection, and fire or smoke control interfaces before work begins.
Controls turn hardware into a building system.
Define enable logic, common or individual speed commands, pressure reset, fan staging, lead lag rotation, run feedback, module alarms, sensor failure, communication loss and power recovery. Control grouping should match the approved design and commissioning plan. Redundancy must be demonstrated at the required duty. Simulate one module unavailable and check total airflow, static pressure, motor loading, reverse flow protection, sound and stable control. Counting spare modules is not the same as proving that the AHU still meets its acceptance criteria.
Commission with an equal boundary.
For both baseline and final tests, record airflow, static pressure, electrical input, speed, filter condition, damper positions, coil state, temperature, sound and operating mode. Trend the BMS after handover so unstable staging or drifting pressure reset does not hide behind one successful test.
Only then report outcomes.
Separate measured fan input from modeled annual energy, and document normalization for schedules, weather, occupancy, and filter loading.
State uncertainty and excluded loads.
Without customer-grade records, this video does not claim a universal savings percentage, payback period, or named project result. The handover package contains the AHU drawing, airflow and pressure schedule, complete pressure path, baseline measurements, annual operating profile, available space, module out requirement, acoustic limits, power and controls, installation window, commissioning method and savings boundary.
With those inputs, another engineer can reproduce the selection and acceptance logic. For a project review, contact Longwell.